Good afternoon, class 9th. I hope all of you are fine. And now we'll continue from where we left off, where we were studying the changes of temperature and the effect the temperature has in change of state. So you had studied about boiling, which the liquid was going to a gaseous state. Then you studied about condensation, where the liquid was coming from a gaseous state to a liquid state. And you studied about melting from a solid state to a liquid state. Now we'll study the fourth kind of change that we observe, and that is called freezing. Now in freezing, as the word suggests, the process of changing a liquid into a solid by cooling is called freezing. So what happens is the liquid is cooled and it changes to a solid. Okay, so more and more we cool the liquid, the energy of the particles keep on decreasing and the particles keep on coming closer together. So that is why they go from a liquid to a solid. So in water we know, if we cool water below 0 degrees Celsius, that is, we get ice. So water is your liquid and ice is your solid. Okay, so write down the definition. The process of changing a liquid, into a solid by cooling it is known as freezing. Okay, so write this down. Freezing also means, if you want another word, you can write solidification. This is a different word for freezing. Solidification. It also means the same thing. Also, it's the reverse of melting. So now, what would be the freezing point? Write it down. Pause the video and write this down. So now we'll look at what is the freezing point. At any temperature you cannot cool, okay. So at 0 degrees Celsius, when we cool water, so that becomes the freezing point of water. So at the temperature at which the liquid cools to a solid or starts becoming a solid is called its freezing point. So write down the definition of freezing point. The temperature at which or you can write below which, the liquid changes its state to a solid is called its freezing point. Okay, so write it down. So now we have observed some changes, and now we'll be moving on to the fifth type of change that you observe, and that is your sublimation. Fifth change is sublimation. Here, what did we study? We have a change from directly solid to a gas. No liquid in between them. For what all changes did we study? Solid to liquid, liquid to solid, and we studied liquid to gas and gas to liquid. Now this is the fifth type of change, that is solid to gas. This is called sublimation. Okay. Now in sublimation, what happens is, there are some very rare solid substances that directly vaporize to gas. Okay, so write down the definition first. The change of a solid directly into vapors is called sublimation. Okay, on heating. vapors on heating is called sublimation. Also in sublimation, after you've written down this, the process of a gas changing into a solid, both these processes are called sublimation. Okay, so when a gas directly converts back into solid, this is also known as sublimation. Or the solid that is obtained by cooling the gas here is called the sublimate. When a gas is directly cooled to a solid, it's called a sublimate. So in this also you can write another definition, second definition, that is your definition 2. You can write the changing of vapor, directly into a solid is called sublimation. Okay, now let us look at some examples of sublimation where this happens. Now the most important daily life example that you have to write the word sublimation for is naphthalene balls. Naphthalene balls are the white colored balls that you place in your woolen clothes. So after a few days you will see that those balls have completely disappeared. So what happened is those naphthalene balls underwent the process of sublimation, and all of those naphthalene in those balls has directly evaporated into air. Naphthalene balls used in storing of wooden clothes to save them from insects and other things. Wooden clothes. Okay, so this is your first example. Then another example, second example is ammonium chloride. Ammonium chloride, that is your NH4Cl. If it is a solid, okay, this is your ammonium chloride. So this is your solid. When you heat it, remember this symbol, this is for heat. It directly changes into its gaseous state or vapors. Okay, NH4Cl. More common substances that undergo vaporization: iodine vapors, the bluish in color. Okay, so iodine also from solid it goes directly into vapors. Then more examples: camphor, that white colored substance that you use in pujas and all, that is called camphor. Okay, so all of these processes undergo sublimation. Now one last example we'll look at is your carbon dioxide. So you will learn a new term, solid carbon dioxide. Just a second. Fifth example, CO2, carbon dioxide, when it is a solid, this is also called dry ice. Write it down. This is called dry ice. Solid carbon dioxide is called dry ice. So when you heat it, it directly converts into also carbon dioxide gas. CO2 gas. Carbon dioxide in solid state is called dry ice. Okay, you can write it down. So this was your sublimation. And now we will look at one last thing in temperature, one last topic that you have to study is the term latent heat. Latent heat. Now what is latent heat? Okay, to understand that, I'll demonstrate to you an activity. Okay, suppose you have taken water in a beaker, you placed it over a tripod stand and you are heating it. Okay, now when you are heating it, you put a thermometer inside. Now listen to this part very carefully. Okay, you put a thermometer inside. So first, initially you will start the temperature. You will see the temperature is rising, and at one point it will reach 100 degrees Celsius. This would be 100 degrees Celsius. Okay, then you will see that steam is starting to come out of it, and you will see that no matter how much more heat you provide, this 100 degrees Celsius will remain constant. That is, when water is changing from liquid to a gas, the temperature is remaining constant. Okay, so the temperature is not changing at all. Here, what is happening is, all the heat that you are providing here is being converted to energy to convert this water into the vapors. Understand this. The heat that you are now providing, the temperature of the water is not rising anymore. It's remaining a constant 100 degrees Celsius. Your thermometer is in water. So now what is happening is, all the heat energy that you are providing is being used to convert this water into steam. Okay, so that is why there is no rise in temperature. The temperature remains constant. So this is known as the latent heat of evaporation or vaporization. So let us write this. The first one is latent heat of vaporization, when liquid is being converted to gas. Okay, so you can write down the heading and now write down the definition. Write this down first. Once the water begins to boil, the temperature remains constant. I'm writing in short, remains constant at 100 degrees Celsius until all the water has changed into steam. Until all the water has changed into steam. Okay, so now you write the definition below this. After writing this, you write the definition below it. The latent heat of vaporization of a liquid. The latent heat of vaporization of a liquid is the quantity of heat the SI unit of heat is joules. Okay, so the quantity of heat in joules required to convert 1 kilogram of the liquid to its vapor, 1 kilogram of liquid to its vapor without, very important, this is without the change in temperature, without any change in temperature. Write down this definition. The latent heat of vaporization of liquids is the quantity of heat in joules. In joules, you can put in bracket also, required to convert 1 kilogram of the liquid to its vapor state without any change in temperature. This is how we measure the latent heat. So if you have understood latent heat of vaporization, we will move on to the next one, that is latent heat of fusion. That is when you take, again to understand this, we'll take a beaker, we'll fill it with ice cubes. Okay. Now again you put a thermometer inside it. So you will initially see that the temperature is below 0 degrees Celsius. Then the temperature will slowly rise to 0 degree. Okay. It will be somewhere here, 0 degrees Celsius. And this 0 degrees Celsius will remain constant. You're providing some heat from down. So it will start melting into water. But till the ice is completely melted to water, this 0 degrees Celsius will remain constant. You won't see a rise in temperature. Till the entire ice is melted into water, the temperature will remain constant. Why? Again, the heat that you are providing is being converted to energy to break the bonds of ice and convert it into water. So this was your latent heat of fusion. So write down. You can now write down the heat which is going into ice, the heat which goes into ice while melting does not increase the temperature. This is known as करके latent heat of fusion. This is known as latent heat of fusion. So you will write down the definition now. Pause the video, write this down. Then you write down the definition. The latent heat of fusion. The latent heat of fusion. Fusion also you can write melting. The same thing, okay? Of a solid is the quantity of heat of a solid is the quantity of heat, again in joules, required to convert the same definition, okay? Required to convert 1 kilogram of solid to liquid. Is the definition over? No. Without, very important, without changing its temperature. Okay, so this is very important. Make sure you write the T also there. Without changing temperature. Pause it, write down this. So this was your latent heat. I hope you understood. This is the heat that when the change of state is taking place, temperature remains constant. Okay, very important topic. This is latent heat. Understood. We'll move on to our next topic, and that is, now temperature is over. You're done with temperature and the effect of temperature. Now we'll study the effect of pressure. Effect of pressure. Pressure also has very similar effects. So most important thing that you will be studying is gas to a liquid. Okay? Gas to a liquid. You can liquefy certain gases by applying pressure to it. Okay? So what happens is, you will take a test tube or a tube. You have some gas, you will take some gas in it, and then you will put a piston, like a syringe, okay? Basically the same principle of a syringe. You will put a piston, and then there are gas particles here. They are free to roam around. Now, what you will do, you will push the piston down. You will push it down, and now the gas particles have come very close to each other. So here what is happening is they are completely compressed. Okay, so compressed, and then if you even cool it a little bit, okay, after compress, draw this, compress and cool. What happens is this liquefies and this changes into a liquid. Okay, so now the gas has been liquefied. So let's see some examples. First of all, write this. Gases can be liquefied by applying pressure, that is P stands for pressure, and lowering temperature. Okay, so gases can be liquefied like this, and let us look at some examples. Oxygen gas to oxygen liquid if you apply pressure. Okay, this is how we liquefy oxygen in cylinders. Liquid. Where does it apply? Oxygen cylinders. In hospitals you have seen patients being given oxygen from a cylinder, those masks that come. So in oxygen cylinders, what happens is in oxygen cylinders, all that oxygen is liquefied at a very high pressure in these cylinders, and then the oxygen is stored inside it as liquid, and then whenever needed, the pressure on it is released a little bit, so it comes out as gas. Okay, so this is the example of oxygen cylinders. Very important, note this down. Then the next example that all of you know of is compressed natural gas, or your LPG. LPG, liquefied petroleum gas. Right? You can write this down. Liquefied petroleum gas, which comes in your cylinders at home. Liquefied petroleum gas, there also this is used, where all that gas is compressed into your cylinder, and then as and when released, you release the pressure on it. So as soon as you release the pressure, the liquid changes back into gas, and you use it for your heating purposes at home in your stove. So that is your LPG. Similarly, your CNGs in petrol pumps, compressed natural gas, CNG, right? CNG which you fill in your cars, compressed natural gas. This is also another example. The same way this gas is also compressed completely. Okay. Then you can write down one example of gas to a solid also. Gas to a solid. And one important example in gas to a solid is carbon dioxide gas. You studied, no? That solid ice, dry ice that you studied, carbon dioxide. So when you apply high pressure to it, it directly solidifies. Okay? And this becomes dry ice. This is called carbon dioxide in solid form. Okay? So this was your effect of pressure. I hope you're writing it down. Pause the video and keep on writing everything down in your copy. Now, next topic that you'll study, one final topic that you need to study is evaporation. All of you have heard this term in class, lower classes also. You have studied about it really nicely. So let us look at it. What is it? You will study about evaporation. Okay. So today we will just start it off a little bit. So what is evaporation? When any liquid, okay, you expose it to air. what happens is slowly and slowly the volume is decreasing. Okay, that is, the liquid is evaporating to a gas. So this is called evaporation. What happens is the process of changing into vapor even below its boiling point is called liquid. Okay, so we'll understand it thoda sa better. Now you've studied that the boiling point of water is 100 degrees Celsius. Now you take a plate, you put some water on it and you leave it out in the sun. After 2 or 3 hours, you'll see that this plate has completely dried off. But when you touch the plate, it is not that hot. So that means 100 degrees Celsius was not there. You have to understand the difference between evaporation and boiling here. Okay, there's a big difference between evaporation and boiling, and that's what you need to understand. What's happening here is this liquid has not reached its boiling point, but it is still changing into vapors and the plate is drying off. So what is happening here is the process, write down the definition, then we'll go into a bit more of explanation. The process of a liquid, changing into vapor or gas even below, very important, even below its boiling point is called evaporation. Okay, is called karke you write evaporation. So this is the definition of evaporation. So what happens in evaporation is there are some particles, always in a liquid, there are some particles, okay, that have high kinetic energy. I'll just write Ke for kinetic energy. So they have very high kinetic energy. There are some particles in a liquid. So these particles on the surface of the liquid, they break off. They break off from that force of attraction and they move as vapors. So slowly and slowly, each of these particles start escaping. So the fast moving particles of the liquid are constantly escaping to form vapor. Okay, so the fast moving particles, especially on the surface, constantly keep on escaping to give us evaporation. Now in the next class, we will look at what are the factors that affect evaporation. Okay, so from the next class, we will do this final topic. What are the factors that affect evaporation? And with that, we'll close the chapter off with some questions in the next class. Okay, so now for today, finish all these notes that you have done today. Okay, and we'll do the rest of the portion in the next class. Thank you and have a nice day.